I have this list of numbers written out in Mathematica, and I'm about to define it to be the variable myList, and then I want to get what are the three smallest numbers inside of myList. And you can tell that I haven't defined myList already because it's in blue. So watch how after I evaluate this expression, it turns to black. So now myList is in black. And my goal is to find what are the three smallest numbers in myList. Finding the smallest number in myList is pretty easy. I can do min of myList. Okay, there's -20. But finding the three smallest numbers, that's going to take some more work. So the key idea is to use the built-in function sort inside of Mathematica. And we can get help on it by looking up $sort. And so it says sort sorts the elements of the input. So in our case, it'll be myList. Here they just call it list. Sorts the elements of list into canonical order. So let's try it out. Let's try sort myList. So it looks pretty good, but notice there's some strange things here, like why is pi bigger than 100 in this canonical order? And the problem is that Mathematica, it's treating these integers here, it's treating them differently from how it's treating these expressions. And if we were to go deeper into the documentation in Mathematica by clicking on these arrows here, then we would see more about that. But I don't care so much about what it's doing here. What I care about is how to fix it. So let's make a new list. Let me call it new list. And here I'm going to make just the exact same thing as myList, but I want to evaluate all of these expressions. So I want square root of 51. I want that to be replaced by some decimal approximation, and same with pi. So new list, this is a good chance to use what I call the second iterator. Table, and I'm going to get the numeric approximation of x for every x inside of myList. So you can see that the integers look basically the same. They just have this decimal at the end of them. But square root of 51, that's been replaced by 7.14 ... And pi, it's been replaced by this 3.14 ... So now this new list is something that I can sort. So sort new list. So this looks a lot better. Here I have -20, here I have -3, here I have pi, here I have 5. So what if I want to find the first three entries in this? Well, just looking at it, I can tell what they are. They're these three. But what's the programmatic way to do that? So let me call this sort. Let me call it sorted list. And I want to find not just what's the minimum, but what are the three minima of this? What are the three smallest numbers inside this list? And how can I do that? Let me show you. What I want to get is I want to get not just the first entry in this list, but I want to get the first three entries in this list. And one way I can do it is instead of doing double brackets with 1, I can do double brackets 1, semicolon, semicolon, 3. So that's going to get me all the first three entries, 1, 2, 3. And that's a good way to do it because if I wanted to get the first 6 entries, I could get the first 6 entries just as easily. Or if I wanted to get the second through the 6th entry, I could have gotten the second through the 6th entry just as easily. If I had wanted to, I could have also gotten the first 3 entries by hand by putting as the input to these double square brackets this little list, 1, 2, 3. And there's the list of the first entry, the second entry, the third entry. What if I want to get the 3 biggest entries in the list? Well, that's not quite as obvious how to do it. I use negative. So -3, semicolon, semicolon, -1. And that gives me the 3 biggest entries in this sorted list.